Hello, in this lecture we find out the area of the green shape. In the drawing we have three identical squares. One side of each square equals to 2 units in its length. In addition we have this green shape that is actually the green right triangle. This is a right angle, therefore it is a right triangle. So our task is to find out the area of this green right triangle. So first of all, we create the Cartesian system in our drawing. So this line will be the x-axis, and this line will be the y-axis. We define this point as point O. Point O is the origin of this Cartesian system, and the origin of a Cartesian system equals to 0, 0. The coordinate x equals to 0 and the coordinate y also equals to 0. It is the beginning of x-axis and also beginning of y-axis. In addition, we define this point as point A. What are the coordinates? Actually, this is the x-axis and this part is the positive part of the x-axis, and this is the negative part of the x-axis. Likewise, this is the positive part of y-axis and this is the negative part of y. So what is the coordinates of this point A? Actually, first of all, we know that we have here three identical squares, and therefore if one side of each square equals to 2, then all the other sides must be also equal to 2. So this side equals to 2, 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 and this side also equals to 2. So there are three identical squares. So what is the coordinates of point A? So this is the positive part of x-axis and this is the negative part. So from point 0 we have minus 2 plus minus 2 plus minus 2, that is minus 6. So the coordinate A of point, the coordinate x of point A is minus 6. Well, this point is minus 6. This is the length of this point. So, and what is the coordinate y of point A? This is the positive part of y-axis, and the length, this length equals to 2 because it is a square. So the coordinate y of point A equals to 2. So point A has the two coordinates, the coordinate x equals to minus 6 and the coordinate y equals to 2. Likewise, we define this point as point B. Actually, we don't know the coordinates of point B, therefore we define it as the coordinate x as x1 the coordinate y is y1. Okay. This is the diagonal of the square, and note that the diagonal of any square bisects the angle of the square. Therefore, this angle will be equal to 45 degrees inside, and the other half must also equal to 45 degrees inside. According to the rule that the diagonals of a square bisect the angles of the square. Each angle of a square is 90 degrees, and the diagonal bisected, so each half must be equal to 45 degrees. This is, of course, a right angle. So, what is the slope of the straight line BO? The slope of the straight line BO equals to the tangent of the angle that the straight line BO creates with the positive x-axis. So this is the angle that the straight line BO creates with the positive x-axis. And it's equals to 45 degrees plus 9 degrees, it is 135 degrees. And the slope of the straight line BO, that is defined as M, again M is the slope of the straight line BO equals to tangents of the angle that the straight line BO creates with the positive x-axis. That is actually 135 degrees. So M equals to tangents 135 degrees. And you know that tangents 135 degrees equals to minus 1. Therefore, we found out that the slope of this straight line BO equals to minus 1. MBO, that is to say, the slope of the straight line BO equals to minus 1. What is the equation of the straight line BO? Actually, we have the function of an equation of a straight line, or y minus y1 equals to m times x minus x1. Point O lies on the straight line BO, and therefore we can substitute x1 by 0 and y1 also by 0. Again, the coordinates of point O, that is the origin of this continuum system, equals to 0, 0. So you can substitute x1 by 0 and y1 also by 0. And we get that the function of the straight line BO equals to, we have y minus y1. y1 is 0, so y minus 0 is y, and is equals to m. We already found out that the slope m of this straight line BO equals to minus 1. So we substitute m by minus 1 times x minus x1. So it is x minus x1. x1 is 0, so x minus 0 is x. So in total we found out that y equals to minus 1 times x. Minus 1 times x is minus x. So in total we found out that the function of the straight line BO or the equation of the straight line BO is y equals to minus x. So you know, this is the straight line BO, and the function of this straight line BO is y equals to minus x. In the next step, we will find out the slope of this straight line AO. Repeat again. We'll find out the slope of this straight line AO. We know that the function of a slope, m is a slope, equals to y2 minus y1 over x2 minus x1. Use this formula in order to find out the slope of this straight line AO. This is point A, and it is equals to minus 6 and 2. The coordinates of point A is minus 6 and 2. We define minus 6 as x2 and 2 as y2. Likewise, we have point O. Point O is the origin. So point O equals to 0, 0. So we define 0 as x1 and the coordinate y is y1. Again, x1 equals to 0, y1 equals to 0. When point A we have x2 equals to minus 6 and y2 equals to 2. So we just have to put the data of our two points A and O inside this formula for the slope of the straight line AO, and this way we find out what is the slope of this straight line AO. So according to this equation, we have y2 minus y1. y2 is 2 minus y1. y1 is 0 over x2 minus x1. x2 is minus 6 minus x1 is 0. So then we found out that the slope of the straight line AO equals to 2 over minus 6, that is minus third. Okay, so the slope of the straight line AO equals to minus third. Okay. And we have a rule, that is actually rule 12. Basically rule 12. According to rule 12, so I think quickly on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, that is to say they are perpendicular to each other, then the slope, and we know that the slope of the first line is m1 and the slope of the second line is m2, then the following equation is to m1 times m2 equals to minus 1. So according to rule 12, if we have two lines that are perpendicular to each other, then the product of their slopes will be equal to minus 1. Again, the multiplication of the slope of the first line by the slope of the second line will be equal to minus 1. So we can implement rule 12 in our drawing. In our drawing, those two lines perpendicular to each other. They create between them angle of 90 degrees. That is to say, the straight line AB is parallel to the straight line AO. So, and we just find out that the slope of the straight line AO equals to minus third. We define the slope of this straight line AB as M2. And according to rule 12, the multiplication of the two slopes of two perpendicular lines must be equal to minus 1. So we define the slope of the straight line AB as M2. We already found out that the slope of this straight line AO is minus third. So according to rule 12, the product of the two slopes of two perpendicular straight lines must be equal to minus 1. So the slope of the straight line AO is minus third. Times the slope of this straight line AB is M2. So the product of the slopes of those two straight lines that are perpendicular to each other must be equal to minus 1 according to rule 12. So minus third times M2 equals to minus 1. Here we will multiply this equation by minus 1. So here, minus times minus is plus. So in this side of the equation we have m2 over 3 equals to minus 1 times minus 1 is 1. So m2 over 3 equals to 1. Here we will multiply this equation by 3 and find out that m2 equals to 3 times 1 is 3. So the slope of this straight line in bit is m2 equals to 3. Now it is very easy to find out the equation of the straight line AB. Why? Because we have one point A is definitely located on the straight line AB, and we have the slope. If you have a slope at one point of the straight line, you can easily find out the equation of the straight line. So the equation of the straight line AB, according to the formula, that says that the equation of any straight line equals to, if you have the value of one point of the straight line and also the slope, you can find out the equation of the straight line. According to the formula that says that y minus y1 equals to m is the slope, times x minus x1. x1 and y1 are the two coordinates that we know the value of them. In this case, x1 equals to minus 6, because we know that point A equals to minus 6 and 2. That is to say the coordinate x of point A equals to minus 6, and the coordinate y of point A is 2. Or, in other words, x1 equals to minus 6, and y1 equals to 2. Okay? So, and we already found out that the slope of this straight line AB equals to 3. So m equals to 3. Now we just have to put the data for straight line AB inside this general formula for a straight line. In this way we find out the equation of the straight line AB. We do it now, we get it y minus y1. y1 is 2 equals to m. m is 3. The slope of the straight line AB is 3. So we have x minus x1, so it is x minus x1. x1 is 6, so it is x minus 6. So today we found out that the equation of the straight line AB equals to y minus 2 equals to 3 times x minus 6. So y minus 2 equals to 3. X minus 6 is x plus 6. So then we found out that y minus 2 equals to 3 times x plus 6. Here we'll open the brackets on this side of the equation, and we get that y minus 2 equals to 3 times x is 3x, and 3 times 6 is 18. So then we found out that y minus 2 equals to 3x plus 18. Here we add 2 to this equation, and finally get that y equals to 3x, 18 plus 2 is 20. So we found out that the equation of the function of this straight line AB is y equals to 3x plus 20. And we already found out that the equation of the straight line OB is y equals to minus x. This is point B. That is a common point that belongs to both straight lines. Point B is definitely located on the straight line AB, and point B is definitely located on the straight line OB. So point B is a common point that belongs to both straight lines. If a straight line is located, if a point is located on a straight line, it means that it satisfies the equation of the straight line. Okay? That is to say, if we take point B and put the values of point B inside this equation, that is to say, we substitute x by x1 and y by y1, this is the coordinate of point B, then the left side of the equation will be equal to the right side of the equation. So you can actually definitely substitute x by x1 and y by y1 because of the fact that the straight line B is located, point B is located on the straight line AB, and therefore point B satisfies this equation. So again, the function of the straight line AB is y equals to 3x plus 20. So we substitute x by x1 and y by y1, right? Because of the fact that the value of the coordinates of point B are x1 and y1. So here we substitute y by y1 equals to 3x plus 20. We substitute x by x1. Again, we will substitute x by x1. So y1 equals to 3x1 plus 20. Repeat again. Because of the fact that point B located on the straight line AB, it must satisfy the equation of the straight line AB. So we substitute the x by x1 and y by y1, and here the left side of this equation 1 must be equal to the right side. Likewise, point B is located also on the straight line OB, and the function of the straight line OB equals to y equals to minus x. So we substitute y by y1 and x by x1, and the equation that will be created will be correct in the sense that the left side of the equation will be equal to the right side of the equation because of the fact that point B is located on the straight line BO. Again, we substitute y by y1, so it is y1 equals to minus x, so x by x1, this is point B. So in total, according to equation 2, we found out that y1 equals to minus x1. So we have two equations for the value of y1. In the next step, we get equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. So y1 according to equation 1 equals to 3x1 plus 20. And it must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So in total, according to equation 3, we found out that 3 times x1 plus 20 equals to minus x1. Here we relate x1 to this equation 3. And again, that according to equation 3, 3 times x1 plus 1 x1 is 4 times x1 plus 20 equals to 0. Here we will subtract from this equation 3, 20. We get that according to equation 3, 4x1 equals to minus 20. Here we divide this equation 3 by 4, and finally get that x1 equals to minus 20 over 4 is minus 5. So here, the coordinate x of point B is x1, and x1 equals to minus 5. Write it down. x1 equals to minus 5. And according to this equation 2, y1 equals to minus x1. But x1 is minus 5. Again, y1 equals to minus x1. And x1 is minus 5. So y1 equals to minus 5, that is 5. So y1 equals to 5 units in itself. y1 equals to 5. So this is y1 by 5. In total, we found out that the coordinates of point B are minus 5 and 5. The coordinate x equals to minus 5, and the coordinate y equals to 5. Our task is to find out the area of this twin shape. It's actually the area of the green triangle ABO. We know that the area of any triangle equals to the base of the triangle times the height over 2. So the green shape, that is the area that we're looking for in this question. The area of the green shape is equal to the area of this green triangle ABO. Green right triangle ABO. We know that the area of any triangle equals to the base of the triangle times the height over 2. We will choose the base of this green right triangle ABO as AB. And the height is of course AO because it's raised 90 degrees with the base. The height is AO divided by 2. So the area of the green shape, that is the area of the green triangle ABO, equals to AB times AO over 2. In order to find out the length of side AB, we just calculate the distance between points A and B. Likewise, in order to find out the length of the height AO, you just have to find out the distance between points A and O. And we know that the formula for a distance between 2 points for example, between points A and B is equals to the square root of x2 minus x1 square plus y2 minus y1 square. Okay, that is the distance between any 2 points. It could be A, could be any point, and B also could be any point. Okay, so we use this formula in order to find out the distance between points A and B. So we define minus 5 as x2, the coordinate x, and 5 as y2. Likewise, so this is point B. Here in point A, we define minus 6 as x1 and 2 as y1. Now we just have to put the data of those two straight lines in this general formula for the distance between 2 points, and we find out the distance between points A and B, the length of side AD. The length of this side AB. It is the base of this great triangle ABO. So according to this formula, the distance between points A and B is equal to the square root of x2 minus x1. x2 is minus 5. Minus x1. x1 is minus 6. So it is minus 6 squared plus y2 minus y1 squared. y2 is 5 minus y1. y1 is 2 squared. So inside the root we have minus 5 minus 6 is plus 6. So get minus 6 is plus 6. So minus 5 plus 6 is 1, and 1 square is 1, plus 5 minus 2 is 3, and 3 square is 9. So in total, inside the root we have 1 plus 9, that is 10. So in total we found out that the distance between points A and B, the length of side AB, is equal to the square root of 10 units in its length. So it is known AB equals to the square root of 10 units in its length. The length of the distance between points A and B is also the length of side AB, that is equals to the square root of 10 units in its length. Likewise, we calculate the distance between points A and O. The distance between points A and O is the value of the height. Okay? The distance between points A and O is the height of this green triangle ABO. Okay? So the distance between points A and O that is to say AO. But before that we define point O, that is the origin of this Cartesian system. Define the coordinate 0 and the coordinate x that is 0 as x1, and the coordinate y of this point O as y1. Likewise, we define the coordinate x of point A as x2, and the coordinate y of point A as y2. Okay, x2 equals to minus 6, y2 equals to 2. Likewise, here x1 equals to 0, and y1 also equals to 0. The distance between points A and O is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So it is the root square root of x2 minus x1 squared. x2 is minus 6, minus x1 is 0, so it is minus 6 minus 0 is minus 6, minus 6 minus 0 is minus 6, and minus 6 squared is 36, plus y2 minus y1 squared. y2 is 2, minus y1 is 0, so 2 minus 0 is 2, and 2 squared is 4. So in total inside the root we have 36 plus 4 is 40. So in total we found out that the length of side line AO, again the distance between points A and O is the length of the height AO. Okay? So the height AO equals to the square root of 40 units in its length, and the base, so it is known, and the base AB equals to the square root of 10 units in its length. The base AB equals to the square root of 10 units in its length. The distance between the points is also the length of this side AB. And the green shape, the green shape is actually the area of this green triangle ABO. And the area of this green triangle ABO equals to the base times the height over 2. The base of this grand triangle ABO is AB times the height. The height is AO divided by 2. We already found out that AB equals to the square root of 10, AO equals to the square root of 40 over 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20 and 20 over 2 is 10. So if you want to know that the area that we are looking for in this question, that is the area of this green shape, is equal to 10 square meters in size. If you want to know that the area that we are looking for in this question, that is the area of the green shape, is equal to 10 square meters in size. So, the next step, let's summarize the lecture. Our task in this question is to find out the area of this shaded area. Okay, the shaded area is actually the right triangle. So our task is to find out the area of this right triangle. In the domain we have 3 identical squares. One side of one square equals to 2 units in its length. Again, we have also this green right triangle and this blue right triangle, and our task is to find out the area of this blue right triangle. Here it is green, but it is the same actually. So first of all, we created here the Cartesian system. That is to say, we define this line as the x-axis. This is the positive side of the x-axis, and this is the negative side. Likewise, we define this straight line as y-axis. This is point O, that is the origin. This is the beginning of x-axis and also the beginning of y-axis. Point O is the intersection point between x-axis and y-axis. So it is the beginning of those two axes. And therefore it is defined as 0, 0. Why? Because of the fact that it is the beginning of x-axis and also beginning of y-axis. We know that one side of one square equals to 2, and because of the fact that those 3 squares are identical, all the other sides must be also equal to 2. You can see here. In the next step, we calculated the slope of this straight line BO. Actually, we know that the value of a slope of a straight line equals to the tangent of the angle that is created by the straight line with the positive x-axis. Actually, this is the angle that is created between the straight line BO and the positive x-axis. Because of the fact that the diagonals of any square bisects the angle of a square, this is diagonal that bisects the angle of the squares of the square. Each angle equals to 90 degrees, and therefore diagonal bisects the angle into two halves. The first half is 45 degrees and the second half is 45 degrees. So in total this angle equals to 45 degrees plus 90 degrees, that is 135 degrees. The slope of the straight line BO equals to tangents 135 degrees. Again, the slope is defined as m. So the slope of the straight line BO equals to tangents 135 degrees. Again, 135 degrees is the angle that is created by the straight line BO and the positive x-axis. Okay, this is the straight line BO and the positive x-axis. And tangents of 135 degrees equals to minus 1. That is to say, the slope of this straight line BO equals to minus 1. It is obvious that it is a negative because of the fact that the straight line BO actually from point B it gets down to point O. Okay. If the slope is positive, then the straight line should be actually rise from the left side to the right side. Here it is a negative, therefore it is gets down from point B to O because the slope is negative. Okay. So the slope of the straight line BO equals to minus 1. In the next step, we calculated the function of this straight line BO, or the equation of the straight line BO. According to the formula, actually if you have the value of the slope of the straight line and one point of the straight line, you can easily find out the function of the straight line. We have point O is definitely located on the straight line BO. It is the origin. And you know that the origin of any Cartesian system is 0, 0. So we have 1 point of and the slope is 1. The slope is minus 1. Therefore we can use this formula in order to find out the equation of the straight line BO. According to the formula, that is the equation of a straight line, y minus y1 equals to m, that is the slope, times x minus x1. Again, x1 and y1 are the points that we know the values of it. Here, x1 equals to 0 and y1 equals to 0, that is point O, that is the origin. So we just have to substitute x1 in this equation by 0 and y1 also by 0. Because point O, that is the origin of this Cartesian system, is definitely located on the straight line BO. Okay. So y minus y1. y1 is 0, therefore it is y minus 0, that is y, and equals to m. m is minus 1. Inside the brackets we have x minus x1. So it is x minus x1. x1 is also 0, and x minus 0 is x. So in total we should find out that y equals to minus 1 times x. Minus 1 times x is minus x. So in total we should find out that the function of the equation of the straight line BO y equals to minus x. Again, the function of this straight line BO is y equals to minus x. Okay. In the next step, we calculated the slope of this straight line AB. This is point A. And again, we calculated the slope of this straight line AO. This is the straight line AO. And you can definitely calculate the slope of this straight line AO because of the fact that we know the values of point A, that is what is the value of point the x-axis, the x coordinate of the straight line of the point O, the x-axis, the x coordinate of point A. This is the negative part of the x-axis. This is the positive. So from point 0, that is the origin, we have minus 2 plus minus 2 plus minus 2, that is minus 6. So the coordinate x of the point A is minus 6, and the coordinate y, we have here y equals to 2. Because the graph of this side is 2. So y equals to 2. So the coordinate y of point A is 2. So in total, the coordinates of point A is minus 6 and 2. Likewise, point O is also definitely located on the straight line AO. And point O is the origin, that is 0, 0. And because of the fact that we know the values of the 2 points that they are both located on the straight line AO, we can easily find out the slope of this straight line AO according to the following formula. The slope M equals to y2 minus y1 over x2 minus x1. And we define the coordinate x of A is x2, we know that it equals to minus 6, and the coordinate y of point A is 2. The coordinate y of point A is y2, and we know that y2 equals to 2. Likewise, point O is also located on this straight line AO. So we define the coordinate x of point O as x1, and the coordinate y of point O is y1. And we know x1 equals to 1, 1 equals to 0. So now we just have to put the values of those 2 points, and say this equation for the slope, and we easily find out the slope of this straight line AO. Whenever you have the values of 2 points that are located on the straight line, then you can easily find out the slope of that straight line. Therefore, the slope of this straight line AO equals to y2 minus y1. y2 is minus 6, y2 is 2, and y1 is 0. So 2 minus 0 is 2 over x2 minus x1. x2 is minus 6, minus x1 is 0. Minus 6 minus 0, minus 6 minus 0 is minus 6, and 2 minus 0 is 2. So in total, the slope of this straight line AO equals to minus 2 over 6, that is minus third. Repeat again, if you found out that the slope of this straight line AO equals to minus third. You can see that it from point A it goes down to point O. Why? Because the slope is a negative, it is equals to minus third. If the slope is a positive, then it will actually go from the left side up to the right side. Okay? So we know that the slope of this straight line AO equals to minus third. This is the straight line AB, and because of the fact that those two straight lines AB and AO perpendicular to each other, then the product of their slopes must be equal to minus 1, according to rule 12. Again, if you have two straight lines perpendicular to each other, then the product of their slopes must be equal to minus 1, according to rule 12. Repeat again, rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, this is to say they are perpendicular to each other, and we know that the slope of the first line is m1 and the slope of the second line is m2, then the following equation is to m1 times m2 equals to minus 1. So here, the slope of this straight line is m1, the slope of this straight line is m2, they are perpendicular to each other, they create 90 degrees with each other, and whenever two lines create 90 degrees with each other, then the product of their slopes must be equal to minus 1. That is to say, m1 times m2 equals to minus 1. So you can definitely implement rule 12 in our drawing. Why in our drawing? It is given as a question that this is a right angle. That is to say, the straight line AB is perpendicular to the straight line AO. And whenever you have two straight lines that perpendicular to each other, then the product of their slopes must be equal to minus 1. We only found out that the slope of this straight line AO equals to minus third. We define the slope of this straight line AB as m2. It is unknown. Again, the product of those two straight lines, the product of the slopes of those two straight lines that are perpendicular to each other must be equal to minus 1. That is to say, minus third times m2 must be equal to minus 1 according to rule 12. Repeat again. According to rule 2, the multiplication of the slope of this straight line AO with this straight line AB, with the slope of this straight line AB must be equal to minus 1. The slope of this straight line AO is minus 1. The slope of this straight line AB is m2. So the multiplication of those two slopes must be equal to minus 1. So minus third times m2 must be equal to minus 1 according to rule 12. Here we multiply this equation by minus 1 and find out that minus times minus is plus, which is in this side of the equation we have m over 3 equals to minus 1 times minus 1 is 1. So in total we found out that m2 over 3 equals to 1. Here we multiply this equation by 3 and found out that the slope of this straight line AB equals to 3 units. Now, point A is located on the straight line AB. We know that the slope of this straight line AB equals to 3. And therefore, we can use the previous formula in order to find out the equation of this straight line AB. Again, we have the equation that says that y minus y1 equals to m times x minus x1. We use this formula in order to find out the equation of this straight line AB. Why? Because we have one point, A, and we know that the slope of this straight line is 3. And we have point A. We defined x1 is 1 6 and y1 is 2. And again, it's point A. We defined x1 is 1 6 and y1 is 2. So just put the data of this straight line AB inside this formula, and found out that y minus y1, y1 is 2, so it is y minus 2 equals to m is 3 times x minus x1. So it is x minus x1. x1 is minus 6, so it is x minus 6. So in total, we found out that y minus 2 equals to 3 times x minus 6. X minus 6 is x plus 6. So in total, we have this side of the equation 3 times x plus 6 equals to y minus 2. y minus 2 equals to 3 times x plus 6. Here we open the brackets of this side of the equation. We found out that y minus 2 equals to 3x plus 18. Here we add 2 to the equation. We found out that y equals to 3x plus 20. Repeat again, we found out that y equals to 3x plus 20. So we have found out that the equation of this straight line AB is y equals to 3x plus 20. We already found out that the equation of the straight line OB is y equals to minus x. So we have the equations of those two straight lines, and this is point B. This is a common point that belongs to both straight lines. Why? Because point B is definitely located on the straight line AB, and point B is definitely located on the straight line OB. So point B is a common point that belongs to both straight lines. So it means that whenever you have a point that is located on a straight line, then it must satisfy the equation of the straight line. Again, whenever you have a point that is located on a straight line, then the point must satisfy the equation of the straight line. This is to say, if you substitute x by x1 and y by y minus 1, this is the value of this point B, then it is satisfy this equation. This is to say the left side of the equation will be equal to the right side of the equation, and it also satisfies this equation. The left side of the equation will be equal to the right side of the equation. So we just have to substitute in this equation x by x1 and y by y1, and finally, likewise, we substitute y by 1 and x by x1. This is to say, actually put point B inside this equation and also inside this equation. But again, in this equation, y equals to 3x plus 20, we substitute y by y1 and x by x1, and therefore found out that y equals to 3x plus 20. Here we substitute x by x1 and y by y1, and found out that y1 equals to minus x1. This is according to equation 2, and according to equation 1, we actually found out that y1 equals to 3x1 plus 20. So we have two expressions for y1. And therefore created equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x1 plus 20, and it must be equal to y1 according to equation 2 equals to minus x1. So according to equation 3, if we found out that 3x1 plus 20 equals to minus x1. Here we added x1 to this equation, equation 3, and we found out that 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtracted 20 from this equation, equation 3, and we found out that 4x1 equals to minus 20. Here we divided this equation, equation 3 by 4, and we found out that x1 equals to minus 5. So the coordinate x of this point B, is minus 5. And here we have y1 equals to minus x1. So y1 equals to minus x1, and x1 is 5, so it is minus 5. Minus 5 is plus 5. So in total we found out that y1 equals to 5. That is to say the coordinate y of this straight line, of this point B, is 5. So the coordinates x and y of point B are minus 5 and 5. Okay, the coordinate x is minus 5 and the coordinate y is 5. So if you want to know the value of point B, we have also the value of point A, and we have also the value of point A, of point O, that is the origin of this Cartesian system. Now it is very easy to find out the area of this green shape. It is actually the area of this green triangle ABO. The area of this green shape must be equal to the area of this green triangle ABO. The area of the green shape must be equal to the area of the green right triangle ABO. And we know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green triangle ABO as AB, the height as AO, why? Because of the fact that AO equals to 90 degrees with the base AB, and therefore AO is the height. So AB is the base, AO is the height over 2. So again, we choose the base as AB, the height is AO, because it creates 90 degrees with the base AO divided by 2. Now we have to find out the length of AB and AO. What is the length of AB? The length of AB is the distance between points A and B. Likewise, what is the length of the height AO? The length of the height AO is the distance between points A and O. Okay? And we have a formula that gives us the distance between 2 points A and B that could be unit points. This is equals to the square root of x2 minus x1 square plus y2 minus y1 square. Actually, it is very easy to prove that this equation is true. If you use the Pythagoras theorem, you can easily find out that the distance between 2 points in a plane is this expression. So we have to find out the distance between points A and B, that is the length of side AB, that is the base. We defined the coordinates of point A, the coordinate x is x2, and we know that x2 equals to minus 6. Likewise, we define the coordinate y of point A is y2, and we know that y2 equals to 2. Likewise, this is point B. We define the coordinate x of point B as x2, and we know we define the coordinate y of point B as y2. But here we define the coordinate x of point A is x1 and x1 equals to 6. Likewise, we define the coordinate y of point A is y1, so we know that y1 equals to 2. Okay. Now we just have to put the data for those 2 points A and B inside this general formula. This is the distance between 2 points, point A and B. And we find out the distance between points A and B. That is the length of side AB. That is the base of this green triangle ABO. So AB equals to x2 minus x1 squared. So it is x2, that is minus 5, minus x1, that is minus 6 squared. Again, it is x2, that is minus 5, minus x1, that is minus 6 squared. And minus 5 minus 6 is minus 5 plus 6, and minus 5 plus 6 is 1, and 1 squared is 1. Likewise, we have here y2 minus y1 squared. y2 is 5, minus y1 is 2 square, so it is 5 minus 2 square. y2 is 5, y1 is 2, so it is 5 minus 2 square. 5 minus 2 is 3, and 3 square is 9. So to that we have here 9. So inside the root we have 1 plus 9, that is 10. So in total we shall know that the distance between points A and B is square root of 10 units in its length. So units in its length, this is the length of the base AB. The distance between points A and B is also the length of the base AB. So AB equals to the square root of 10 units in its length. Likewise, we found out the distance between those 2 points A and O. Exactly according to in the same method, using the same equation. Again, the distance between those 2 points A and O is equals to the square root of x2 minus x1 square plus y2 minus 1 square. We defined x2 as minus x, y2 is 2. Likewise, here we defined x0 is x1 and y1 also equals to 0. So here we have x2 minus x1 square, so it is minus 6 minus 0 square, minus 6 minus 0 is minus 6, and minus 6 square is 36. So x1 minus x2 minus x1 square is 36. And we have plus y2 minus y1 square. y2 is 2, minus y1 is 0, so 2 minus 0, 2 minus 0 is 2, and 2 square is 4. So total y2 minus y1 square equals to 4. So inside the root we have 36. 36 plus 4 is 40. So inside the root we have 40. So total we found out that AB equals to the square root of 10 and AO equals to the square of 40 units in its length. And again, the distance between points A and B is also the length of line segment AB. That is the base of this green triangle B. This is equal to the square root of 10 units in its length. Likewise, the distance between points A and O is also the length of side AO. That is the height to the base of this green triangle ABO. So AO equals to the square root of 40 units in its length. And AB equals to the square root of 10 units in its length. Our task is to find out the area of this green shape. So the area of the green shape equals to the area of this green triangle ABO. The area of the green shape equals to the area of the green triangle ABO, and the area of the green triangle equals to the base of the triangle times the height over 2. We choose the base as AB, the height is AO over 2. Again, the base is AB, the height is AO over 2. AO is equals to the square root of 10 units in its length, AB equals to the square root of 40 units in its length, AO equals to the square root of 40 units in its length divided by 2. Square root of 10 times square root of 40 is square root of 400 over 2. Square root of 400 is 20, and 20 over 2 is 10. That is to say, if you found out that the area that we are looking for this question, that is the area of this green shape, equals to 10 square units in its size. Okay, thank you very much.